This is programmable matter. It's also known as 4D printing because the fourth dimension is time. Unlike regular 3D printing, which creates static objects, programmable matter is designed to change shape, color, or other properties in response to a stimulus like heat, light, or moisture. In this video, I'm going to show you some of the most exciting recent developments in this field, some of which have huge potential to disrupt industries and change our everyday lives forever. So let's get started. Most people think of camouflage as something static, a fixed pattern or color designed to blend in with the surroundings. But what if it could do a better job than that? That's exactly what the Defense Advanced Research Projects Agency, better known as DARPA, is investigating with its latest research into programmable camouflage materials. They've created what they call a shape-shifting stick, a thin rod that can morph into different curved or zigzag shapes. It might not seem particularly useful in its current form, but DARPA believes that their technology could be used to create adaptive camouflage for vehicles or even soldiers. Just imagine a suit that could change color and texture depending on the environment. It would make hunters much harder to spot. But camouflage isn't the only military application for programmable matter. Researchers at the University of California, San Diego, have developed a 3D printable plastic that can change its refractive index in response to an electric signal. This means that the material can be used to create lenses that can quickly change their focal length, making them ideal for use in things like in-flight missile guidance systems or periscopes. Medical science has also been quick to embrace 4D printing with one team from Japan, creating a self-adjusting stent that can expand to block an artery in response to changes in blood pressure. Another team at the University of Michigan has developed a programmable implant that can release drugs in response to changes in the body, potentially helping patients to avoid the side effects of chemotherapy or other systemic treatments. But perhaps even more exciting is the potential for programmable matter to revolutionize the way we build buildings. Researchers at the Swiss Federal Institute of Technology have developed a system for 3D printing walls that can self-repair if they re-damaged, eliminating the need for costly maintenance and reducing the environmental impact of construction. Other engineers have created pipes that can reconfigure themselves to avoid leaks or blockages. The possibilities are really endless here, and we're just beginning to scratch the surface. One of the most popular research areas in programmable matter at the moment is origami. By programming materials to fold in a specific way, engineers can create complex 3D structures without having to assemble them afterwards. In 2018, MIT researchers developed a system for 3D printing flat sheets of material that could fold themselves up into predetermined shapes when heated. The technique known as active origami has since been used to create everything from a flat solar panel that unfolds into a large canopy to a compact robot that can unfurl itself to explore hazardous environments. Another exciting development in programmable matter is the creation of robots that can shift shape. A team at Harvard SYS Institute for Biologically Inspired Engineering has created a liquid metal robot that can explore and map out unknown environments. The robot consists of a mixture of gallium and indium that gives it the ability to flow through small spaces and change shape. It has potential applications in search and rescue missions where a human might not be able to reach. But perhaps even more exciting is the potential for programmable matter to help us adapt to the changing climate. Researchers at the University of Leeds have developed a fabric that can change its porosity in response to temperature, making it ideal for use in clothing. The fabric consists of microcapsules filled with a liquid that evaporates as the temperature rises, leaving behind a porous structure that allows air to circulate and cool the wearer. Speaking of climate change, global warming is causing the sea levels to rise, which is threatening to displace millions of people from their homes. That's why we're so committed to reducing our own carbon footprint. But back to programmable matter. Another great potential application is energy. Solar panels are one of the most promising sources of renewable energy, but they have one major drawback: they're fixed in place, which means that they can't always capture the best angle to receive sunlight. But what if they could morph into the best position to absorb sunlight? That's exactly what a team of engineers at the University of Stuttgart have done. They've created a system for 3D printing solar panels that can change their shape, allowing them to track the movement of the sun across the sky and generate more electricity. So when can we expect to see these amazing innovations in our everyday lives? According to some experts, The first consumer applications will hit the market in the 2030s, and I can't wait to see what they have in store. If you want to know more about programmable matter, check out this video next. Don't forget to subscribe for more updates on all things 3D printing and manufacturing. Thanks for watching.